A conducting sphere with radius r carries a net charge positive q. Plot a graph to show the electric field E versus radial distance r to the center of the sphere, and plot an electric potential V versus r graph. For a conductor in a static situation, where do you think you can find the positive net charges? What do you think is the electric field inside? The net charges can only be found on the surface, so it looks like this. And the electric field should be 0 everywhere inside. So the graph should look like this, 0, when the little r is less than the big R. What about the outside of the conducting sphere? That is, if little r is bigger than the big R. If I draw electric field lines for this conducting sphere, I should have no lines inside, but the lines coming out of the positive charges like these. So the lines are all perpendicular to the conductor's surface immediately outside, and we have spherical symmetry. I can compare these field lines to the field lines of a point charge, positive q. The lines will look exactly the same beyond radius big R. So the electric field out here must equal to kq over r squared, which means it is proportional to 1 over r squared. For little r that is bigger than the big R. And if I plot the graph, it should be a curve like this. When the little r doubles, the electric field should become 1/4. When the little r doubles, the electric field should become 1/4 its original value. What about the V versus R graph? Outside the conducting sphere, we can again treat it like a point charge positive q. That is, like all these charges are concentrated at the center. So the electric potential V should equal to the V produced by a point charge, K positive Q over R. V is proportional to 1 over R. So the graph should be a curve like this. It looks kind of like the E versus R graph, but it's not quite the same. For the potential graph, when R doubles, the potential becomes halved, so it does not dip down as quickly as the electric field graph. Now the tricky part is, what is the potential graph like inside the conducting sphere? For a conductor in a static situation, the electric potential should be the same everywhere, the same on the surface and the inside. So the graph should be a horizontal line like this. If what we have is a conducting sphere with radius big R carrying a net charge of negative q, the graphs would look like these, just like those graphs, but negative down here. For the vector electric field, being negative means it is in the negative direction. In this case, it means negative r direction. The coordinate system r is positive for radially outward direction. Since the field produced by negative charges are going to go in that way, radially inward, that's why the electric field is negative. As for the electric potential V, outside the conductor, it is like a point charge. V equals to K negative Q over R. So it is negative down here.